Hi, good afternoon, everyone. It is my absolute great pleasure to have the opportunity to talk to you about where I believe engineering can go with AI. And I'm going to try using the pointer, and it seems to work exactly the same as my pointer. So I'm very, very pleased about this. So I'm going to talk about a few things, and I will start by introducing myself a little bit so that you understand where I'm coming from. And I will talk a little bit about the very origins of engineering as AI and AI as definitions to try and understand how we can blend these together and what we can achieve with engineering and AI. And then I'm going to go through some examples of the 3Ds, the dull, the dirty, and the dangerous sort of already existing applications of AI and robotics. And at the very end, I'm going to reveal what I think would be, perhaps according to some of you, a more utopia-type future with AI. But I just think, wouldn't it be nice if we just had that at some point? So how did I become an AI specialist? Well, of course, I wanted to become a fashion designer. That's how I started. But then my family really convinced that perhaps it's better to continue in my grandfather's footsteps and become a doctor because I could help a lot of people. However, there were a bit of a problem with that because I really couldn't think, what would I do if the state of medicine and what I knew was not enough and I couldn't help people? Could I actually live with that? And also, I really didn't like the sight of blood. So it was a no. Then I really liked mathematics, but I really, really liked mathematics. And I liked teaching. So the next option was going into maths. But going into maths didn't really mean research. It just meant that maybe one person in every year could do research. And you couldn't tell whether you'd become the one person to do that. And other than that, you'd be an educator, which is a really nice profession, but I somehow wanted to be more creative. But I wanted to do all of these things to some extent, and I was rather confused. And then my parents said, how about engineering? They were both engineers, and they thought that maybe as an engineer, I would be a better place to do a lot of these things. And then the final result was to actually study computer engineering, which I did, and then I specialized in artificial intelligence. So I am the director of this, what I think is a fantastic venture. For the first time at my university, we were allowed to create this bottom-up center with 25 academics who are all working in AI and applying AI to various fields. And I was the lucky one who they chose to be directing this venture. And we are going to be 1 year old very soon. If anybody asked me what's the proudest achievement of my professional life, I would say that it's this award which I got from the EvoStar conference, which is for outstanding contribution to evolutionary computation, as that is the field in which I specialize. I do a lot of applications in other methods in machine learning and optimization as well. I'm not very fixated on one particular method like many other people might be. I always look at the problem and try and see which of the methods that we know would solve that problem best. And a lot of the time, it's something that's a hybrid. And neither one, neither the other, but something that we actually create in particular to solve that problem. And that's where my interest is. I couldn't help but give you, because this is all about how I work and how people in my center work, that the guiding principles that we use for everything that we do are based on creating AI solutions together with the stakeholders and trying to go out of our way to find problems where we can use AI to promote fairness and equity. And we use the UN Sustainable Development Goals as our guiding principles. And the details that the principles I'm not going to try and blind any of you, but I don't think I can use this properly. The principles from the AI for People project, which talk about what every AI application should have. So we are trying to do all this, to do things that help people, do things that really do not do any harm, and protect, enhance autonomy, promote justice, and make sure that the solutions that we create, we can actually explain, and explain in a way that the people who are meant to understand actually understand. Now going to the origins, and I'm sure those of you who are engineers would know the first one. The word for engineering is coming from Latin, from the word ingenerare and ingenium, and it really relates to the application of science to the optimum conversion of the resources of nature to the use of humankind. And resources can be material, energy, and the activities usually mean creating something, solving a problem, designing, building, controlling, often under constraints and with limited resources. And I couldn't help but use a picture, an actual picture of a statue from the British Museum of the first acknowledged engineer in the 2600s BC times. Then if we look at AI, well, that's a much younger discipline as such, and the way the AI is defined is actually shifting. So if we look at how one of the textbooks from which I studied AI defined AI, computers that do things at which at the moment people are better. And interestingly enough, when I looked up the definition in the Encyclopedia Britannica just 2 days ago, it was pretty much along those lines, talking about things that people and minds can do. And I was surprised that this is still the case, and I just checked last night, and much to my positive surprise, it's now changed to intelligent beings. And I quite like that, because we are looking at not only what we as humans can do, but we are also trying to learn and look at what other species who perhaps 20, 30 years ago weren't considered intelligent, but at this moment in time, we can see that they are intelligent, and how they apply, for example, collective intelligence to solve problems could be very helpful in practical engineering scenarios. And of course, I also have an AI-generated image, but I promise you this is the only one. And mine happens to be generated by Stable Diffusion, and all I asked Stable Diffusion, show me a picture of AI in the classroom. And that's what it came out to provide. And we can now interpret that, if we wish, in any way we like. It's quite helpful that I heard a little bit about governance and regulation earlier, because I want to capitalize on that and say that we also think that it's really, really important, and the more traditional view of creating AI systems and how people, we as humans, accept and trust the AI systems is seen as this sort of triangle where we have regulatory bodies, the AI system creator, which would be the software engineer, the machine learning expert, those who really put these systems together. And then there is the AI system, and the human is in the middle and decides to trust all these systems. But in a team of people who we've been meeting since 2018 in a setting called Trusting Intelligent Machines, we've been discussing that this model is really not quite so accurate, and we actually have more like 5 different things. And as we go over time, we realize that the technology, out of all these potential driving forces, is driving more and more what we are doing. So it is really important that we consider all these aspects, and we look at how exactly we respond to this. And if anybody is interested, that's the paper that we wrote. And this year's workshop, the paper that we are going to write is going to come out. It's not yet done. It's going to come out maybe January time. I think that when I got asked to say what can engineering do with AI, I was more thinking that actually it's not only engineering doing things with AI. AI is also, or those of us looking at AI, we are also being helped by what engineering does. So it's more like a symbiosis of the two. So now I have a question for you. And please just raise your hand if you think that if your house is on fire, you would call the emergency fire service, if you think that's the correct answer. And who would call their insurance company? This looks like a really silly question. So now I'm going to ask you, of course, we all got the right answer. An even sillier looking question, right? If your house is on fire and the fire service is there, would you send them away so that you can install a burglar alarm? So raise your hand if you think it's a yes. So can I safely assume that you would all say no? Of course, it's not the right thing to do. But if we are to use this analogy and look at attention and resources that are towards big societal challenges and looking at what this horrible, malevolent, general artificial intelligence might do to us, it's the exact same thing. So would we want to turn attention away? What's imminent, like poverty, lack of water, basically killing our environment, and look into putting more and more into what if this AI would come and try and get us. So we really need to be careful. And I've taken this analogy from Shannon Waller's very recent book, which is a fantastic book. And it's for the general public and trying to bring into attention what we as people should do about, and not just the scientists, but the people who are deciding about where the funding goes. So I think that this gets us to the point that in order to progress, we do need to look at the past, but not just regurgitate the past in a way that quite a lot of these ChatGPT and similar generative AI systems are doing. But try and look at that's where we were in the past. This is where we are now. Look at past mistakes, things where progress actually happened, and try and transfer that to where we are now and where we might be, where we'd like to be. So I came up with, because this is used a lot in the industry, but more towards robots, but we could see robots as embodied AI agents, the dull and the dirty and the dangerous. So I'm going to have 3 examples, and one of them is not necessarily all about me, but it happened that I had to come back from Valencia on Monday. And you will get to see what happened. In the past, we would travel in all sorts of ways. Maybe our ancestors in horse-drawn carriages. Now we have cars, autonomous cars, trains, planes, and the like. After having been at a very intense summer school, I was going to come back on a plane, switch over in Amsterdam. I had signed up to the WhatsApp messaging of the airline, so I was like, okay, whenever they have anything, they'll communicate. About half an hour before I got to the airport, sitting on the metro, I received a text message. Your flight has been delayed by 1 hour. Okay. My second flight was supposed to be 50 minutes later, so that's clear I'm not going to make it. So what do? There is no help desk whatsoever. I have to queue with all the people who are dropping off their bags, checking in because they have a single flight, and eventually the person there helps me. We figure out which flight to book the following day, but no hotel. No, I can't do that. For that, you need to figure out what you do in Amsterdam. I can't tell you where it is. When you land, you ask somebody there. Okay, I ask somebody there, they point me to another place to go. I run along with all the other people who had the same problem. Then we queue outside what looks like an office, and then suddenly the man in front of the office, talking to people, pointing them, go that way. When my turn comes, go that way because this office is closing at 10. And you need to go to some other office, you need to go out, find our office by the departure. Can you tell me which departure? It's a big airport. No, just go and find it. Okay, I find it, get my bag, find it. Then I get there, get a number. This is fine, it's with a number, you can see it, wait. Then the security guard comes, this office is closing at 10 o'clock. You can't wait here. Okay, what do I do? Those are the self-service machines. They'll sort you. Okay, there's no other solution. I go to a self-service machine. After convincing it to get my passport, it prints me the voucher, all the information there. I can go and have everything done. Could this be done in some better way with what we have at the moment? Of course it could be done in a better way. I don't need to dream of something very utopistic, just by perhaps better coordinated, faster communication, better integration between what the various communication systems and the people are doing. This could be done better. And maybe it is. It's just not happened in my case. Now, if I wanted to look at something like a longer-term future, I would try and see maybe we could have stress-free, more efficient and more effective way of reorganizing our schedule. And maybe we can do that instead of communicating with various systems, various people running around in places. Maybe we could just talk to one agent who may be human and sorting us out on various online systems. Maybe it's an intelligent agent that artificial intelligent agent that sends us to the appropriate humans and how to communicate. But I think that's within our reach. In terms of looking at something that's dirty, there are lots and lots of examples. I just picked one because I really like the idea of not having people to do that particular job. And that is about looking at what's inside sewage pipes and deciding whether those pipes would need to be refurbished. And this little robot, I'm not sure whether any of you know about this company, Red Zone, they created this autonomous sewer inspection robot for the first time in 2009. So this is actually recent past and present, and they do impressive things with these robots. And I just looked at one example where they would inspect 127 miles of sewer pipes in 30 days and provide sufficient information for the decision makers to actually decide which pipes to replace and what to do with them. Now, in terms of the future, of course, we can think, okay, so that's sorted. You just need to really be rich enough to afford to get these robots to go and inspect the pipes. But I was thinking beyond that, in a slightly more distant future. What if we had less waste, less sewage, if we could find solutions to use that? And that is actually also something that is happening. And perhaps some of it can be transformed into bioenergy and biofuel. And that's something that engineering can do. And that also applies to what I put in the title for waste and rubbish, because we are drowning in the rubbish that we collect. And yes, we are helping it with recycling, but a lot more could be done in terms of reducing that. Now the third D, the dangerous. And I was quite pleased that in the roundtable discussion, the same example came up, the Fukushima disaster that happened in 2011, because I want to build on that. This is, of course, an absolutely terrible, tragic accident caused by a natural disaster, but it was the second worst ever nuclear accident. And if we look at that, 12 years along, it was in August 2023 that they said they would anticipate that it requires 30 or 40 more years of painstaking work to remove the nuclear waste. So in terms of future, where do we see AI helping with these things? AI and not just the algorithms, but the embodied agents, the drones and the various robots. We could certainly use them, and they are already being used for rescue, for decontamination operations. We could do this by commanding them at distance. We could do this by giving them some level of autonomy. And what we could also do beyond this, to have much earlier, accurate and interpretable predictions of when disasters might be happening. And I think I saw somewhere one of the exhibitors talk about better weather predictions. And that is certainly one thing that could could fuel this. And again, this is something where integrated human-machine solutions are required. So I don't think that we will have, in the very near future, something that would solve it all for us and just give us the red alerts and tell us exactly what we needed to do. And with what we know today, it's always best to let the human decision maker have the opportunity to override if there is a situation that needs to be overridden. And I think I'm going quite fast because I only have one more slide, which means that you will have the opportunity to ask me easy or not so easy questions. And this is where I'm going to try and reveal what my vision would be for this future. In the sort of nearest future and already happening, there is this, instead of having this initiative that instead of having an AI, what is called an AI arms race, where all the nations globally compete, who's the first to achieve this, who's the first to achieve that, to basically look at collaborating. And that was again listed, I think, as number 7 of the 10 things to be learned from the past. That is really important to do things collaboratively. And this project is led by a very famous and very well-known researcher who's actually a historian and is writing about AI and making policy recommendations. She's written the book called AI Needs You. I forgot to put the link here, but you can find the book online as a PDF file as well. And it's quite an interesting book from the perspective of somebody who looks at it from the history perspective. And now the question about how far. And I've heard this question in the roundtable for IoT, and it's sort of, is it the question in terms of distance, or is it the question in terms of achievements? And I think that my answer is going to be for both, and hopefully it resonates with people in the room, because I think that we can do more about going to space with the help of AI. And I would envisage something. Of course, I'm not sure how many of you, maybe by show of hands, know of the film. Have you seen the film Surrogates? Some of you have. So this is about, so I'm just going to very briefly explain a situation where people are in their homes, they don't go out, and they have humanoid robots that act in the real world on their behalf, and they are actually controlling these robots without feeling any pain or any of the repercussions. The plot itself and all the murderous details that happen afterwards are not relevant for what I'm going to say. It's just this idea that we would have robots that act on our behalf without us having to be hurt. So they go out, they do the stuff that we can't or won't do, and then we can sit and watch. So what I would envisage, but of course, I don't know how many years, or maybe just months from now, because if we think about flying, in 1903, New York Times said it will take 10 million years for humankind to achieve flying, and it was several weeks after that that the Wright brothers actually demonstrated that that was possible. So I might be telling you about this now, and some of you might come back and say, actually, we might have that very, very soon. So what I envisage is, because we are, as engineers, we are about doing things for people, helping humankind, and I'm also part of doing AI for good. So I'd like to see how robots and AI are helping people, and doing this at all levels. So imagining a colony where we have robots that test the environment. First of all, they somehow get transported to this very far distant star, and they look at all the aspects of living, rather than sending people who get trained over a decade how to live in a colony and who know that they have a one-way journey and never to come back. Instead of that, I much prefer to have robots do this and to also have ways of communicating with them. And I put together a list of things that I think are absolutely necessary for this to happen. There are more, and of course, those of you in the room might tell me more about your specific kind of engineering, but I think that communication and transport and the speed of communication and transport are really, really essential. So this is needed for the transport from Earth to the space colony and also for the communication. For the communication part, this could possibly be enabled by what is known as quantum entanglement in quantum computing, and also in terms of transport, in terms of achieving higher speeds. Physicists are talking about folding space-time, and that may be something that's achievable. Of course, I'm not a physicist, so I cannot really answer that question. I'm just very fascinated about the opportunities that might bring. And then we get to sort of really ground to earth, very technical AI things that are within my reach and where I think that AI specialists can help. And one of them is, for example, more optimal packing solutions. If we are to send out whatever equipment, we really want to use the space on the spaceship as optimally as possible. And finding a way of packing everything that we have under constraints in an optimal way is a very hard problem, is what is called an NP-hard problem, and there isn't a known optimum for it. So we can work towards it, but we don't have known optima for it. We can work towards more optimal solutions for complex path-finding problems. Again, you might think that finding a path on a surface is a problem that is solved, but it's actually not completely solved in an optimal way. There are various algorithms that give you good solutions, but not necessarily optimal solutions. For example, there is the so-called rapidly exploring random tree algorithm, and in fact, one of my colleagues at the summer school where I've been used this as a challenge for her team to get the students to find some solution for this particular problem based on the RRT algorithm. And if we look at what happens, assuming that we can transport the robots, we can have the communication, but what do we need those robots to be able to do so that the experiment, if you like, or the test is as close as possible to our reality? And then we need to look into the direction of the area of artificial intelligence that is called artificial life and evolutionary robotics. So this is again something that has been researched for many, many years. They have a yearly conference, they have a journal, and they are absolutely fascinating findings. In fact, I am told that physical reproduction of robots is very near. So where robots left alone can actually in some way get to the point of reproducing. Of course, don't imagine humanoid robots. They are little more down to earth, perhaps worm-like robots, but not humanoid robots. And also, what is perhaps even more important is to understand how, if we have this sort of communication, if, let's say, people on the Earth are guiding this robot colony, in what way they can influence that in a positive or a negative way, and whatever the robots communicate back, how exactly is that going to influence the people? And there is research going in this direction, and a colleague at the University of Trieste is actually doing such work. And I think with that, I actually finished exactly on the spot, for time is up.
Thank you very much.
So thank you. My pleasure.
The question there.
Okay, it's very interesting. It's all very refreshing to hear somebody do understand the first words. One thing, so I think my experience of the AI acts like large randomly faults is mainly beyond through machine learning, punishing machine learning. And I think, obviously typically you have a lot of training data that you're trying to sort of optimize some parameters within a particular model. Then it's optimizing the behavior to the world sort of really up and a theory. To what extent have we got sort of ideas that AI might be able to go beyond the training data? It was sort of and so being able to describe the situation is still mainly not sort of predicted.
So I'm going to give you a short answer, and then if you'd like, I think we can talk about this more. I will be here till the very end of the conference, so I'm not running away back to Birmingham. I prefer to stay here a bit longer. So you are quite right that, and I should have put up the picture which shows, I usually do that when I teach students about this fascinating area of nature-inspired computing. What are the different areas of AI? And actually, generative AI is just one area, but it happens to be the one that is attracting so much attention that the world seems to forget almost about anything else. And if they remember, the only thing they remember is machine learning. And machine learning, the way it's conceived, is very, very different from human learning, and it's very, very rigid. And there are sort of classification problems, regression problems that we could use, clustering problems, and that's about it. The area of so-called reinforcement learning is closer to how we are learning, and that's an area where with continuous learning, we can expect that a system can get prepared to situations that haven't been seen before. So in a nutshell, reinforcement learning means that when a model initially learns something and it's executing a step, if it's in the good direction, it gets a positive reinforcement, a reward. If it's a step backwards, it gets a punishment. And that way, you can actually get to better solutions. So a team of colleagues are working on looking at traffic in a junction based solely on the images that are being recorded, and they pre-train their model on simulated data, and then they transposed it on real data. And their model, which is using some very sophisticated deep reinforcement learning method, can actually go from sunny weather to rainy weather to snowy weather to all sorts of weather conditions. And this can be done so the images are captured with very basic cameras, yet the predictions are very, very good. So I'm not sure whether that answered your question. Another area is what is called open-ended evolution, which would kind of get us out of this sort of very, very rigid world of how machine learning is operating at the moment. Thank you.
Any other questions? Oh, question over here.
Hello.
I was just wondering further to the reinforcement learning and things that are equivalent. So there's people who are teaching me computers how to do this, and so and we all experience unconscious bias. And I was just wondering if that is something that is being taken into account when you're teaching them these skills and reinforcing positive or negative things with them. So, for example, if I was going to use AI to find me people to employ and play them, would you ever create that AI of conscious bias essentially come out in that?
It definitely would, and it has. So some of you might know of the scandal around Amazon hiring, when it turned out, you have a moment to explain? So that was some years ago, and it was absolutely scandalous because the models were absolutely created in an unconscious manner. It was not the intention of the creators to discriminate between women and men. But because the model was trained on previous hires, and previously they'd already been perhaps biased, or they were hiring more men than women, the model, because it's trained to optimize and find the features which are the ones that discriminate best, they found that it would be better to hire men rather than women in positions. And this came out, and it was a big scandal around it. There is the facial recognition as well. Did any of you know of Timnit Gebru? So she used to be an AI ethicist at Google, and she eventually left. And it was probably about 6 or so years ago. And now she's continuing her ventures in working towards unbiasing the systems. So one of the things that these slightly earlier AI systems did, because they were facial recognition, let's say for police or any other situations where we need to see who is on the CCTV camera, because those were trained mostly on white faces, they would do all sorts of strange things if the person wasn't white. And it turned out that if a person who's black holds a white mask against their face, they get recognized better than if they actually have their own face. So one thing that is happening in the field is trying to unbias the methods and trying to look at, first of all, find if there is some bias in the data or in the method, and try and actively works against the bias and unbiasing the data. But I don't think we can say that the methods that we currently have, the methods themselves, reassure us that they'll never be biased. The first step is to recognize. And if I have time, I can give you one more recent example, which is, again, once you learn what it is, it sounds obvious, but before it wouldn't. So a colleague who happens to be a sports coach as well and has access to a lot of healthy athletes who are keen to participate in studies, was doing a medical AI application. And for the study, for diabetes, for the study, they recruited a lot of potential participants, but quite a large majority of the participants happened to be healthy, who were conducting a much more active lifestyle compared to the typical person. And once they realized that the algorithms were returning things that didn't quite apply to the general population, they decided to create separate models. So one way of finding if you know that your data is patchy, to create separate models for certain characteristics, and then you have a better chance of getting less biased results. Sorry, I can go on forever.
No.
Please stop me.
Thank you very. Oh, there's a question at the back.
Isn't that like the old statistical problem, garbage in, garbage out? And maybe with real application of AI is determining where that statistical problem reshaping.
That is also possible. So I don't know whether that's the only way, but I believe that people are trying to do that alongside other methods. When we are looking at feature generation or going beyond correlations, for example, between features, and looking at what characterizes of the data, that can happen. But this is so working with huge amounts of data and coming up with models that represent the data are not the only thing that AI can do. So that is definitely a very important thing. And I think I overheard somebody in a coffee break saying that anyone who has some data and applies some algorithm on it, they will say that they have AI. So that's another perception of AI. But also AI is also about understanding what it means to be intelligent and what sort of things we could do which are not machine learning.
Right, thank you very much. We're going to have to call it a day there. That was excellent. Thank you.